Okay, let's try again. I think I've reconfigured, and it certainly looks like we're now getting audio. But are we? And see. Okay, we now have audio, so let's start again. Welcome to this live stream of how to program a RTk.GPIO board. We've just gone over a bit without the audio, but I'll restart it. So today I'm going to be programming up the traffic app using the RTk.GPIO board. We're going to be using Ubuntu as the operating system we're programming in. It's simplest at the moment, and it also shows you what you have to do if you're using a Raspberry Pi and Mac as well, I believe. I don't have a Mac, so I can't guarantee that yet. So let's get going in a minute. Yes, I have a loud keyboard. It's what I prefer. Cherry MX Blue, I believe. I'll probably go over what I'm using. I've got a camera set up live on the RTk.GPIO board. It is here. It's not just there on something which isn't. It's real. And it's connected over micro USB to my computer. My computer's having to work quite a bit as it's live streaming as well. So the great thing about using the traffic app is that we can use, it's got 4 outputs and a input. The input's a button, and we've got 3 LEDs. We're just going to be programming the LEDs and maybe the buzzer today. The button should be later on this week. There's a software issue at the moment, but that will be fixed. So let's get going. So the instructions are semi-correct. It will probably change a little with bug fixes and improvements, but we'll see how we go today. And of course there will be errors, but that's the early software. So I'm going to first navigate to our GitHub page and download the code. So if I go to the development branch, this is the software in development at the moment. And then if I go to, let's download a zip version. Extract to home. Okay, so that's the Python library downloaded already. And technically you're now ready to get going. If you're using Linux or Mac, I probably will have a pip package, I think it's Python pip, ready for when it's more finalized. At the moment I'm just leaving it as the development state it's in. So if I go into a program using gedit changes, I'll quickly install a better IDE. Yep, Genie's now installed. There we are, nice IDE. So if I were to get up a demo program, we'll go through what we've done and what you'd do on a Raspberry Pi instead. Let's just change the font so we can see it better. There we are. So this is a piece of code that I wrote, which was used in the Kickstarter video, and as you can see, the first couple of lines are generic Python from time import sleep. We've got a variable for our time delay to copy out throughout the program, and then we've got this first line here, which is the first main difference. The library is called NEIO at the moment. This may change, as the code was based off of a piece of software called NEIO by David Whale. He's helping out with this project a little and may be working on it a bit more in the future. And at the same time, any improvements I make will be sent upstream to his package. For most programs that use just simple RTk.GPIO, to make your Raspberry it work on your Raspberry, you type in RTi.GPIO. To make it work on the RTK board, it will probably be NEIO or it'll be RTk.GPIO. At the moment it's NEIO during in development. We've got some variables set up for each of the GPIO pins. At the moment the numbering is BCM. That's because it's what is the official standard by the Raspberry Foundation. If you follow many of their tutorials, they'll opt for BCM. I've always gone for BCM as well. And if you need it where you can't remember the pin numbers, there's a multiple range of add-ons and accessories which tell you what GPIO pins are what on your Raspberry. I'm just seeing if I have one in clear view, which I don't. That's well prepared for me. So let's go. So that line's the same. These lines here are the same as you would in RTi.GPIO. This code should work no issue if you change it to RPI on your Raspberry. And we've got an input here. At the moment the input doesn't work. That's because unless you've got a physical pull up or pull down externally, the command to set up in software doesn't work yet, but that will be fixed. And then we've got the bit of code here which goes try and finally, while true, GPIO output red true, sleep yellow, yeah, green, and then if I just modify this a bit, we should have it where just by running this code we have it where the lights on the traffic light will go red, yellow, green, red, yellow, green, whether I've got the colours the wrong way around. Yep, so if I just fix that, red is 24, yellow is 23, green is 22. The only thing at the moment is if I go to run this program, we do get an error. That's because I've not technically plugged in the board into the virtual machine, so we're going to go over that and just see how easy it is on Linux, and I might have time to reboot into a Windows virtual machine to see how it goes on Windows. I know it does work on Windows because I've tested it, but whether the virtual machine will work or not I don't know. So if I go to VirtualBox, it shows up as a USB 2.0 to serial adapter. And then now if I go LS USB, we should have the HL340 USB to serial adapter. It's a slightly cheaper one which is on many popular Arduino clones. We've actually found it really good to use because it's a decent package, the drivers all seem work fine, and the great thing I found is that there's been issues with some of the other chips not being as reliable, and the main brand which is reliable, you can't guarantee them to not brick the device even if you buy the genuine chips. So that's why we've gone for this one. It actually works very well. So now we have it where we should have our serial device. If I go dir/dev, we've now got a TTY USB 0. The only thing is, you'll also find if you're not set up on the group to be able to dial out, we should get a permissions error. So I'm going to have to run this program as sudo. I should be able to go in this way. Build, set build commands, C, Python. So if I now run this program as root, we should now, if I press enter, see the traffic hat light up. And it's as simple as that. We've not had to change our code from the standard RTk.GPIO library. We've just had to connect to a USB device, run it as root, check that it's installed, and we're away blinking LEDs. Yeah, sorry about the delay on the camera. The camera doesn't want to work that fast today. See if I can fix that. Video capture device properties. Let's capture that resolution. Nope. Nope. There we are, let's see how that goes. Should be slightly faster now. There we are. And it is as simple as that to get going. There's no trickery at all or much else to it apart from basic RTk.GPIO. So let's stop the program, and it even has the same bugs as the Raspberry does at the moment. So if I press stop, oh, I think I stopped it at the right time there. Yeah, the camera's got a real big delay on it at the moment. Come on, camera, be nice. There we go, that should fix it. No, wrong thing, computer. There we are. I don't want to do that either. Okay, so we've now got that done, and just to show it's not a scripted bit of where I change the code, I can change any of these around. And now, once I click go, it'll run in that little combination. So, next, I think that was pretty much it. It really is that simple. You don't have to do a lot of work at all. The GPIO cleanup works the same way, but there's a little bug in that, so now I've stopped it. The two LEDs are left on. So you even have the same bugs. And if you ever find that it crashes out or it just won't respond, simply unplug it from your USB port. Let's see, which one is it? That one there? That one there? Nope, not that. Not that port. Can't even find what one. There we are. And it's reset. Yes, just pop over an email and I'll have a look at what's wrong with your debug clip. Thanks for backing. And that goes for everyone. Thank you for backing the Kickstarter so far. We're at about 46% of the way through. We're hoping to get funded by the end of next week, hopefully, if everything goes okay. Is there any projects you'd like to see in the future? We're going to be doing more live streams every couple of days. We might go through how to do the display project as shown in the video. That's very simple, and we should hopefully have another announcement in the next few days of what will be in the GPIO experimenters pack, but it'll probably include 3 LEDs, 3 resistors, nice quality jumper wires, not the, if I get an example of the jumper wires we ship. These nice jumper wires with plastic ends, not the horrible rubber ends. Thanks Cole, that's actually where I got the inspiration from to make it, is schools, because from where I've taught in schools and helped out at clubs and got feedback, one of the issues they have is that they only have a limited budget, and if they've got a Raspberry Pi club, they can't justify buying add-ons for their Raspberry Pi club and not to be able to use them in any other lessons. So by doing this, we're able to then bring GPIO to even the normal lessons for schools, and unless you're in year 7 at the moment, no other years are going to get the microbit really, unless the schools keep them. So it's a great way of being able to do this type of things in the way that people are used to now, and you can use the same great add-ons. That's the main, another big benefit. We've had our robot controller working on it perfectly, the traffic cat as you can see, and a few other brands of add-ons. More are going to be supported soon. I think I had a question about Scratch GPIO support. We're not sure whether it will be supported. I know that Simon Walters, who made the unofficial one on the Raspberry Pi, has backed the prototype pledge, and I'll be probably helping in getting it going. For GPIO 0, I'll probably be trying to get that to semi-work. That's going to take a bit of work, and we'll see where we get to with the Kickstarter. Any other language, I'm not planning to make the library, apart from I think C is the only other one I'm thinking about doing. Java I'm not, and not really many others I'm not thinking about. However, I'll be documenting how you can talk to the microcontroller. It's simply over serial, and it uses a bit of trickery where you send there's 25 letters in 26 letters in the alphabet, and then if you send the letter and then the number 1, that letter will then correspond to a GPIO pin, which then turns on that GPIO pin. So it's quite a simple thing to start figuring out. At the moment the library is very basic, and we've got to do pull up, pull downs, possibly event triggers, speed improvements. We've found this microcontroller really great compared to an Arduino, because it's just so fast compared to the Arduino microcontroller, and we've got room to be able to expand, whereas an Arduino we've already used more than what will fit on inside an Arduino chip, so that's not currently possible. Let's see if we can quickly go through. No, I'm not going to be able to do that as I don't have Windows on here yet. I think that is pretty much it for today's live stream. Thanks for tuning in. If you've got any other questions, feel free to pop in the chat box before I go. I'll quickly check the Kickstarter page to see if I've had any. Let's have a look. Let's go that way around. Yeah, that's right as well. A lot of kids are starting to get Python as a basic, and I've recently run a workshop in a local senior school, and kids who they've used Scratch before but they've never used Python before, apart from the ones which learned outside of their own time like I did. They got Python really quickly, and then being able to go in there with a bunch of these boards and be able to do some lighting up of LEDs as well on a budget is really great. And that's the main thing, is that this isn't designed to replace the Raspberry Pi, it's designed to go alongside with it, because not for all use cases you can't always use a Raspberry Pi, and I know in schools getting all the adapters, the SD cards, corruptions, they don't work well for beginners to use if you're just trying to get a bit of Python done quickly. I also had a couple of people, single person or two, ask why is it dearer than the Pi Zero, and that's simply the real cost of a Pi Zero totals up to about the same price. So by the time you get the Pi Zero, about, I think the current price is £4.20. An SD card you're looking between £4 to £5, so let's go forward, that's 8. And then you need to find somebody who can then solder on the GPIO header for you, and you've got adapters and extra bit switches needed. With this, all you need to do is add the micro USB cable, which if you own any modern mobile phone, not even just whether it runs Android, whether it's made in the last 3 or 4 years, you'll likely have a micro USB cable spare. Let's go is there any more questions while I see if there's any on the Kickstarter page? I'm more than happy to speak. There we are. See comments. LabVIEW, I had a couple of requests for this. I don't see why you shouldn't be able to write a LabVIEW library. It does appear as a serial device on PC, so that's pretty quick to get going with. Safety diode. So if I take this apart, we'll quickly go over the safety diode. Let's see. Let's make the webcam bigger. Not the best quality, but let's go to better quality. There we are. Okay, so I've been asked about a safety diode and whether it's possible to add one. So if you have an add-on which requires to power the Pi through the 5V GPIO pin, this diode here, let's see if that re-angles, this diode here will prevent it going back into the USB port. If you power it from this unsoldered pin here, which is on the programming header, it connects to the other side of the diode, so it would connect to the USB port. If you are using a Mac, never power it through this pin, as there is issues with Mac and back powering, and that is our disclaimer to say if you power it through this pin and destroy your Mac, we're not liable. This pin should be fine, as this diode is here to prevent short circuitry. We've also got a polyfuse here which cuts out and increases the resistance if there's anything wrong, and I can even demonstrate this if I get a pin cable header I have spare. I can't find a pin jumper. Let's see. There we are. We've got a pin jumper. So I've just got a generic jumper wire. I'm going to plug the board in. Now in the case of a short, my computer shuts itself down because I've got decent quality parts in my computer. It's got a Corsair power supply. And doing this shouldn't cut down the stream because of the circuitry in it, but if it does, then you know I'm going to go offline. But if I connect this to here, and I believe if I just get a GPIO markup, where's your ruler when you need it? Is it in that box? No. Here we are. Raspberry rulers, really handy. We sell them in our shop. Okay, so I need ground, and yep, I'm going to connect to this ground here, and you can see all that has happened is that the board has turned itself off. If I remove the jumper, it turns back on, and your computer is protected. You can do the same with a 3V pin. You shouldn't do this deliberately, but this is just to show you what would happen. And my computer's still online. If I was to connect these two pins, my computer would go down, so I'm not going to do that. The shipping date is going to vary depending on how long stuff takes. I'm targeting August, end of August, early September. However, on the Kickstarter I have said October, November time in case of delays, and that's one thing I always plan in. Every Kickstarter I've done has either been on time or early. There's a chance this could be earlier, but it purely depends on how quick we can get the software done. Once the Kickstarter ends, there's about a 2 to 3 week period we have to wait before we get the money. Then we've got to get the final prototypes made, tested, which we'll order once the goal is reached, so the quicker we hit the goal, we can then get going with getting the prototypes in. Then after they're back, we can then place the order for all the production batch, and then assuming there's no part shortages, we should be expecting around end of June, early July at the earliest, before we get back the first boards to be able to ship. If the software is all ready by then, we'll be able to ship them. If the software isn't ready, then we'll be waiting for the software and then we can start programming. So that's, but of course if you've backed any of our Kickstarters before, which majority of people I think have, will be providing weekly updates at least, or every time there's a major change. So once the software is done, once the prototypes are done, once we send it off to manufacturing, you'll get informed. If there is any delays, you'll get informed as well. We don't expect any, but if there is, we will communicate it, and that's what we find important. Let's see. Will it be compatible to the code bug? That's a hard one. The code bug I think connects over I2C if you plug it on top of the header, which currently I2C support isn't there. That is a stretch goal, and we would really like to reach that, as it allows us to add in a lot more add-on compatibility. Another question: will you have a bootloader on the microcontroller so the firmware can be updated over USB? Unfortunately not, as this is a embed chip, so it's designed to be programmed by another chip. And we're not planning to have it where the user can update it themselves easily in case anything goes wrong, and then we've got to return it, fix it ourselves, send it back. However, there will be a couple ways. You can then buy the kit to be able to program it yourself. The kit to program it yourself is about £10 to £15. I'm going to see if we can program it using a Pi over the GPIO header. I'm not sure on that yet, but otherwise the kit to program it yourself is about £15, and you just hook some jumper wires up and you're ready to program. Or when we're at Raspberry Jams or events, we'll bring the equipment to be able to program them up ourselves if we then release software updates during the future. And we'll also be offering a service where it'll probably be for 50p to £1 plus postage back. We'll reprogram the board for you, and then if you then send it to us. Will the firmware be open source? Yes, that should be going live very soon. It's still a bit buggy, so I don't want to release it yet. Otherwise, it will be open source. It uses the Embed Classic library, as that was what's out when we developed the software. We developed the software on a microcontroller about a month ago. We've still not settled on what family of the microcontroller we're going to use. It's going to be one of 2 chips, but we know the basic specs are at least what we've got on the Kickstarter page. It might be shipped with better specs. This prototype here is the best one which we could ship. However, we're looking at using another chip just to be able to make it slightly easier for us on the budget. Let's see. Was there any other questions? What screen have we got to go to? Too many screens. Okay. Will pulse width modulation be supported? Hopefully, should do. If so, will it be software or hardware? So, there's essentially two bits of software and there's the hardware method. Hardware may be possible, as from what I remember, majority of the pins have PWM. Software, it won't be where the software runs on the Python script on the computer. It'll probably be where the microcontroller software does it itself. If it does do that, then it shouldn't be much of a delay at all, as you've got a 48 MHz microcontroller not being asked to do a lot, so it should be able to keep up. It's not like a Raspberry Pi where it's got to manage the OS, manage the programs you're running, manage the Python program, manage your Wi-Fi, etc. It won't be supporting Raspberry Pi EEPROMs. There's no benefit of this supporting it, and that's not going to change. And that is it. Oh, and will it come pre-assembled? Yes, as it is a real pain soldering up this little chip here. That took me quite a while to do, and I have solder paste and stencils and heat guns and toaster ovens. But yes, once again, thank you all for backing. We'll be posting another update probably tonight or tomorrow. This live stream will be saved to YouTube, so you can re-watch it, you can skip through parts. I'll be putting jump points on it where you can jump to question and answers or programming. And hopefully one day next week I'll do a tutorial on Windows. And that is it for this live stream. So once again, thanks for tuning in. Please share the Kickstarter with anyone you know, and we should have information about the GPIO goodie pack soon. It will include the jumper wires, either a small or big breadboard, I've not decided on that yet, and one of these displays. We'll do a tutorial on this display. These are really nice to get going, because then you can display messages from your computer. You could even make a game monitor or something. And thank you. And I'm now going to go offline. And let's see how to do this. Oh, and in this Pimmeroni stream today. Yep, go and see them at 3. I'm not always up to the top. Let's see, and turn on. And we're now should be going down. And it hasn't. Let's get some music playing again.